Hello kids, welcome to UIL Science. I'm Paul Kennedy and today's problem is a kinematics problem. A plane with an initial velocity of 200 meters per second accelerates at a constant rate for 3.5 seconds, traversing a distance of 900 meters. During the time it was accelerating, what is the final velocity of the plane? So here's our plane and it's traveling with an initial velocity such that initial velocity is 200 meters per second. It's accelerating with a constant velocity and it's going to travel some distance, d, which is 900 meters. And it wants to know what is the final velocity of the plane. The two equations we know are that x is equal to x naught plus v naught t plus 1/2 at squared, and v equals v naught plus at. Now if we assume that x naught is equal to 0, when we fill this first equation out, we get that 900 meters is equal to 0 meters plus 200 meters per second times 3.5 seconds plus 1/2 a, which we're solving for, times t, which is 3.5 seconds. And we're going to square that. By solving for a, we get that, let's do first do our math here, 900 meters is equal to 700 meters plus 1/2 a times 12.25 seconds squared. Solving for a is going to be equal to 900 meters minus 700 meters, now believe in showing all your work, times 2 divided by 12.25 seconds squared. And our acceleration is equal to 32.65 meters per second squared. We now know the acceleration, so we can shove it in our second problem, which is v equals v naught plus at. We know the initial velocity is 200 meters per second plus the acceleration, which is 32.65 meters per second squared, times t, which is 3.5 seconds. When we solve that, we end up with 314.29 meters per second, which is close to our answer C.